Hello, welcome back to More Fun Fixing It. I've got another ZX Spectrum repair to do here today. I'm trying to batch a few of these out so that I can get some videos banked so I can work on some other things and more involved stuff. I promise I will be doing the Silver Label C64 soon. Also, I promise I'll be doing Swampy soon. I've made a lot of promises. Please don't hold me to them. So I've got this one here which says black and white stripes. I will show you exactly what that means. Here we go, black and white stripes. There's a few other bits and pieces in there as well. The Steam Card Pro is already plugged in, so that's working nicely. There's no actual activity, and if I press reset, nothing changes on the screen. I'm pressing it multiple times now. NMI, nothing, but the lights go out on the Steam Card Pro, which means the reset is actually going low. So it also says on here, ULA good, dash CPU, bad power jack. So let's test this bad power jack first. Yeah, that's actually affecting things on the screen. So before I go any further, I'm going to test the voltages. I have actually, this has been triaged before, and in the triage I will have checked to make sure that all the resistances that I normally do check on a ZX Spectrum are as they should be. So I wouldn't have just plugged this in without trying that first. Voltages. So the input voltage is slightly low. Output voltage is perfect. And then we've got the 3 voltage rails. Minus 4.6 is a bit off. 12.2 and 5.046, which is bang on. I think they're all fine. I think the voltages are okay. I'm sure that the power jack is bad. But what else is wrong? So at the moment it's good enough to do some testing with. As long as I don't mess around with it, it should be okay. But what I do need to do is check for some other things. The next things to check for are clock and reset. Now the clock is pin 6 up here on the CPU. There's also a clock coming out of the ULA, but I don't have the pin out handy for that. But I don't need it because I've got the Steam Card Pro clipped in here, and all of the edge connector breakout testing points are here, including clock, which is this one, and that's it's messy. It's quite messy actually, but I think that's okay. Let me just change a setting on my scope. It just cleans things up, so it makes it more of a, yeah, that's more what I'm used to. And the other one is reset, which is currently high. So if I turn the computer off and then turn it back on now, it takes a second to go high. And if I press the reset button, you can see that's the computer is being reset. It hasn't got a composite mod at the moment, so I've got the Henry composite mod clipped on. Now I've got a tick on the ULA. So I've already tested this ULA in another machine and it's okay. So there are some options here. It could be memory, it could be the ROM, and it could be the CPU are the main suspects. But the other big suspect will be the capacitors. I am going to bet that this one just needs a recap. So this could be a very short video. Yeah, the CPU is not particularly warm. That cap always gets quite warm there, 33, 34. So it might be quite resistive. So I've got a couple of things I need to do here before I start pulling any chips out on a machine like this. Is well, I could either just recap it because it is an issue 3. Looks like it's had some recapping done to it in the past, so there's a different colour cap there, although these all look like they're from either the 80s and they were changed back then, or they were done like this in the factory. But we've got some mismatched caps going on around here. I'm going to just use my little handheld multimeter thing here, which does a really good job of testing capacitors in circuit. I mean, it's not a perfect thing. So I'm still going to get told off for doing it this way, But this does give me a good idea if something is really bad. If a cap has got high resistance, like this one has, it's flying around all over the place. Hang on a sec, let's try and get a better connection. That's, oh no, that's good, 4 ohms. The one next to it, 2 ohms. 18 ohms on a 1 microfarad cap, not terrible. It probably would still function, but worth changing, I would say. On this 4.7 microfarad, it is 4 ohms, and that's actually within spec, I would say, within tolerances. This is the reset cap. This is C27, and that's 15 ohms, and that's a 22. No, that's a 1. That's 1 microfarad. I think that was measuring right. Yeah. Okay, so that's actually, that's a bit high in resistance, but not too bad. This one is a 22, and that's at 5 ohms, and the capacitance is okay. 100 microfarad cap is measuring it absolutely perfect. These are on the 12 volt rails. This one, not, oh no, it's just bad connection. No, 794 milliohms. Yeah, that's apparently less than an ohm. If I'm reading that right, I might not be. 2 ohms on that one, but that's 32 microfarad, so it's a bit high. And 3 ohms on that one, not too bad. And oh, that one's 46 at 4 ohms. It's not the best, but what else could it be? A quick thanks to PCBWay for sponsoring this repair. I often see here on More Fun Fixing It that sometimes a repair isn't just about swapping a capacitor or replacing a bad RAM chip. Occasionally the original board is corroded, cracked or completely destroyed by an over-enthusiastic repair. When that happens, often the best fix is to reverse engineer it and get a brand new one built. That's where PCBWay shines. You can design a replacement board for a vintage machine, upload the files and have a professional quality replica sent to you in no time at all. It's the ultimate way to save equipment that would otherwise be scrap. And if you're restoring something with a missing trim piece, a broken bracket or even a smashed case, their 3D printing service can reproduce those mechanical parts too. Don't let a bad board end the repair. Check out the link in the description to get your replacement parts made. Thanks to PCBWay. White border often means that the CPU is running. And if I scope around on the CPU, actually if I scope around on the edge connector stuff on the Steam Card Pro, black border now, which could be bad CPU. So we've got the address lines. It's address 0, 1, 2, 3. IRQ, can't, rogue. I think that's IRQ request is just a bit high, that's all. Ground, these are the video signals coming out. There's a few video signals on the edge connector. Bus request is high, reset is high, address 7, 6, 5, 4. ROM chip select is high. So the ROM is not being selected. Bus activity, I think, or bus acknowledge. Address 9 and address 11. I wouldn't expect anything on those. 10, 8, refresh, looks good. M1 looks good as well. 12 volt, minus 12 volt, no, 12 volt, I don't know what that is. Weight is high, minus 5 volts. Write, read, IORQ, MREQ, memory request I think. Halt is high, that's good, so the CPU is not halted. NMI, well, we can test NMI with, yep. Int, all right, and then data 4, data 3, data 5, data 6, data 2, data 1, and data 0. And then data 7 is up here. And address 13 and 14. So you've got a full picture there. If anybody wants to armchair fix this, the only one that stands out to me is the ROM select line is not, there's no activity on it. Where was that? ROM chip select is just high. Do we get any activity if I... It's kind of like a little blip. See that? Right, so that's bus request, I think that is. That just goes straight to high without that blip. But the ROM chip select, oh, there's a little, no, it goes nah. Wonder, could it be the ROM? Right, so we've got two jobs I'm going to do first. One is to change this power jack, and the other one is to recap the whole board. Don't always recap them. I think this one is, because this is an edge case and I want to rule out the any problems with this being capacitors. Oh, loads of cracked solder on the back of this this power jack. That probably just needs a reflow actually. Yeah, I just want to rule out the capacitors being the problem before I start pulling chips out of everywhere else. I think that might work. Well, it's not going to work now, but at least I reckon the power socket is okay. All right, let's wiggle it. I'm wiggling it and wiggling it, and it's not changing at all. So, yep, just cracked solder. All right, job one, go around marking them all where they are, just to make my life a little bit easier. Now, while the desoldering station heats up, I'm going to just reflow all of these legs and straighten them out at the same time, so that the desoldering nozzle can get onto them nice and easy without damaging the board. It's really easy to damage the board by trying to force the desoldering gun nozzle onto the end of these pins when they're bent over like this against the board. I've actually broken pads doing that in the past. So just for the sake of a minute of going around with some fresh solder, makes things a lot easier. I've left a load of solder there. And makes it so that there's less chance of actually breaking something. We're not here to break things, we're here to fix things. Right, they are all standing up, but I am just going to reflow them anyway, because it makes it easier to... Good thermal transfer with fresh solder. Not the worst ones over here. These 2 points in the middle here, not too bad. This point here can be an absolute nightmare if your soldering iron isn't up to the task of melting all of this solder in one nice blob. A really tricky one. Managed it. It's really good soldering iron this. I highly recommend this one. A Sugon A9. There are newer models of this. I recommend you go and watch Joey Does Tech, who does like more contemporary repairs on PlayStation 5s and Nintendo Switches and things. But he's done a few comparisons of different soldering stations, including a couple of different Sugon stations, which I found quite interesting. Let's go straight for the tough one. A lot of thermal mass on the desoldering gun, so doesn't really struggle with that sort of thing. And I've recently cleaned this out and re-lubed the pump with talcum powder, and that's really worked a treat. It sucks now. Sucks in the best way. Oh, and I've got a new nozzle on as well. Thanks, Chris, for picking those up from Japan. From Japan for me. Everything Hakko is cheaper in Japan. Okay. I'm going to put these on the here in the same order that they came out and test them. God, soldering gun has done such a good job. These are all practically falling out. There you go. Right, now another quick test. These are the 22s. That's down at 15 microfarads, 6.7 ohms, which is over what I would like. That one's okay, 2 ohms and 20 microfarads. This one I think is a 1, and 17 ohms, which is not too bad for a 1. This is the 4.7, that one's fine at 2 ohms. This is another 22, this is the reset cap. No, this is a 1 microfarad at 13 ohms, that one's actually okay. Not too bad. I mean, it's not got much life left in it when I say okay. 5 ohms, 28 microfarad. These are the hundreds, these tested really good in the board. 94 at 1 ohm, that's practically brand new. Probably the new ones aren't going to be as good as that. 98 microfarad, 600 and... that's less than an ohm, half an ohm. I mean, it might just be that they're failing. 16 microfarad, so this is a 22, and that's at 18 ohms. That one's gone. That is definitely gone. Beyond what I would leave. 32 microfarad and 2.4 ohms, so the capacitance is out, but the resistance is okay. And 23 at 3. Now, someone did mention that I should change the frequency on these to measure at different frequencies. So at 100 hertz, that one's reading 9.6 ohms and 28 microfarad. I'm not touching the contacts there, by the way. So this is the one that was bad, and this is at 100 hertz. That's 27 ohms still. Let's go up to at 10k. Yeah, that's not a good reading. I think 1k is reasonable. Yeah, they're all bad. They're all really bad. Right, let's put some new ones in. Okay, so you've seen this a billion times before. I'm going to bring you back after it's recapped. Okay, we're back, and look, it's all done. Let's get rid of those. It went very well, no problems at all. I even composite modded it as well and changed the transistors at TR1 and TR2 to boost the signal a little bit. I have switched it on to test it in your absence, sorry. So I know what's going to happen. But do you think that just changing the capacitors will have fixed this, or is there another issue? Like I said, I know, and you probably know because you've probably looked at how much video is left to go and decided that, yeah, it's not the capacitors. Yep. Now it's a cleaner image. It's just a black and white pattern. Do we get anything with Steam Card Pro now? Still, oh, actually, I'm still on internal ROM. Let's try external ROM. That's interesting. So when this switch here on the Steam Card Pro selects whether the ROM on board the Steam Card Pro is the one that's active or the ROM here. Now, when I was poking around with the oscilloscope earlier, I made a mistake. Someone was probably screaming at me. And I'm not sure if this is, well, I don't know, let's try that actually. So this is with the Steam Card Pro ROM selected. Okay, so, and we get this horrible black screen. And if I scope the ROM chip select line, is that ROM? Yep, ROM chip select, it's just high. But if I turn that switch off, then we get activity. Now on a normal Spectrum, there's a lot more activity than that. And I'm not sure if that's a symptom or the cause. Now I was thinking, because there was absolutely nothing on there when I was looking before, that it might be the ROM. But now I'm kind of leaning towards the CPU because, well, for a number of reasons really. One is that when the computer is running the internal diagnostics, oh look, I've got a white screen that time. No, that's the when it's running the internal ROM, I get a white screen, a white border, and when I run the Steam card, I get a black border. Actually, let's try a different ROM image. So it's ignoring the ROM here. That even if that was broken, unless it was dragging something down really badly, so like trashing the data bus, which it's not, because we can scope the data bus and see that there's normal signals there. I would say it's not the ROM, because it's circumnavigating the ROM, and the only things in play here are everything this side, and this is okay. The address lines and the data lines look okay, so that rules out, well, it doesn't rule out completely, but makes me suspect that the RAM chips are at least functional enough. They might still be faulty, but they're not killing things. They're not stopping anything running. We would get the, have activity, and we'd have a program running even if some of the RAM was faulty, especially on a diagnostics ROM. So if it's not the ULA, it's not the RAM, probably not the logic chips, not the ROM, that only leaves the CPU. I think it's the CPU. I think we should now confidently take out the CPU. I kind of hope it's not, because I've just done 2 ZX81 repairs, and it was broken Z80 CPUs in both of those, and I've got 2 left. I'm going to have to salvage some out of my spare machines. Lovely. Okay, so CPU is here underneath this heatsink. So the first thing I need to do is remove the heatsink. And the 7805 will be all right for a few seconds if I turn it on without a heatsink, but I wouldn't run it for very long. I saw on, it might still be a Patreon video. By the time this video goes out, I'm sure it'll be public. On Adrian's Digital Basement. He looked at some Fami clones, one of the blob chip ones, and it had a 7805 sitting in there with no heatsink in it whatsoever. Obviously wasn't drawing as much current as this does, but still, no heatsink on a 7805 is bold move. Right, to give this every chance of coming out cleanly, I'm going to reflow all of the solder points, all 40 of them, with some fresh solder. So fast forward. As I've reflowed all of those, I pushed the one that most of them were actually really nicely central, but the ones that weren't, I pushed into the center of the hole that they're in, just to make sure that the solder comes out either side. If they're pressed up against one side, then they will stick to that side. If they're in the middle, then you've got a better chance of them just falling out. A better chance. It's quite rare. Lovely. I've switched to this newer tip on my Hako, and it's I think it's a 1.2mm tip, just slightly bigger than the one I was using before, 1mm. This seems to work really well, this one. I don't know if that's because it's new and nice and shiny, or whether it's just better suited for this size of pin and via. Okay, they all cleared really, really nicely, and it looks like all the solder's gone on the other side as well, on every pin. I've got high hopes this will just come out. I'm just going to give each section of pins a little tweak, just to give them a little wiggle. I'm not putting a lot of pressure on here. It's just to see if they crack loose. No. Not this time. No. And it's not worth forcing it because... Oh, I forget one. Yeah, there's quite a lot of solder left. Oh no, there's not really. The other thing I could do is just go along them with a soldering iron and loosen them. Or I could just hit it with hot air. I'm going to try the soldering iron method first. Just for science, just because I'm curious. Did that do anything? Oh yeah, it did. Okay, one side just popped out really easily. And I'm just going to make sure that all of the pins are moving now. They're all moving right. This should just pop out. It's out this end. Yep. Nice. Okay. It's nice to do it without throwing a load of extra heat into the board. So that can't really do it. It's not going to hurt it, but... Now, do I put this in a working one? Or in a working ZX81? Oh no, that means taking a case apart, and I don't want to do that. I've been through probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 15 ZX Spectrums looking for one with a socketed Z80 CPU, and there just isn't one. Aha! Found one. Let's see if it works first. Okay, we have a working ZX Spectrum, and I'm pretty sure it's got a Z80 CPU in it. It might still be a problem because it's an issue 2, and they very often have a spider mod on top of the CPU, and I can't remember what I did with this one. This is my issue 2 from ages ago. Right, so that's that CPU out, and let's get this one in and test it. This will be a definitive answer. Yes, it's a very broken CPU. Okay, that's very good. That's good to know. Look at this, all socketed. Everything's socketed in here, apart from that. Let's make sure that still works. Yeah. Okay, so I'll put that away. And I'll put a socket in the other one, and then we'll see if it works. Right, before I put the voltage regulator back in, I'm just going to test, make sure that this is actually working with a new CPU. And here we go with a Zilog from 2017. This almost doesn't qualify as retro anymore, this computer. His beating heart is 9 years old. Okay, so here we go. It's the same. What? That is really interesting. So the CPU was bad. I will double check that. Actually, did we get anything on Diagnostics now? This is on the, actually. There wasn't very good contact there on the edge connector. So I'm just going to clean that. I have to be a bit careful with this voltage regulator. It's really quite nasty looking, this one. I've got a new, much more aggressive fiberglass pencil. Yeah, this is really very aggressive. It's doing a good job, but I'm a little bit concerned about the this one is going to actually end up with little bits of fibre in my fingertips. I can see the fibres here where I've cleared that up. Exactly the same. It absolutely, well, that's not quite the same, but the same enough that makes me feel that the original problem is still there. Okay, I've grabbed the issue 2 again. I just want to double check that this is working. Well, that's working, so let's see if this CPU is working. You see, that CPU is definitely dead, but dead in a different way. I would expect the same or similar fault. And it's now working again with its original CPU. I'm going to put the other ULA in here just to make sure, because that's the only thing I haven't checked since I did the triage on this one. That socket is not very good. Okay, the ULA is definitely okay. Okay, I found, I haven't got any ROMs handy. This is a scrap board that had a fault that I fixed, which was, well, I didn't really fix a fault, I just found that the fault was a bad ULA. The rest of the board I kind of wrote off for spares, and this is an NEC ROM. I need an NEC ROM in this one. In the issue 3 and beyond, the ROMs could be selected here with these jumpers, and it can be, I think it's Hitachi if you jump the links that way, and NEC if you jump the links this way. I need to rob that out of there and stuff it in there. Look at that, straight out. I'm going to put that back in here. I might put a socket back in this because this might still get used for something. I might even use it in the testing of this. If it's not this ROM, then I think it's going to be RAM. I mean, there's not much left, but I will not start just pulling out RAM chips. I'm gonna wait until tomorrow, till I've got a fresh head, and I'll get out 2 similar spectrums, and I'm going to start scoping around between them to see if I can find anything that's going to point me to what the problem is, rather than pulling out chips. Sometimes I can pull out chips because I've got the luxury of being able to fix lots of machines, but it also means I've got to fix lots of machines, and that puts me under a bit of a time pressure sometimes to actually get them fixed. And as much as I'd love to understand everything that I'm doing, I don't always have that time. Both of those have come out perfectly. Okay, so this is the questionable one. I'm just going to put a black question mark on there. Need a socket. Okay, I'm going to put a known working ROM in here, rather than putting the broken one in another machine, because that's just going to entail... What's that going to entail? No, that means putting another socket in there, and I don't want to do that right now. So let's try this. Okay, that's actually unfortunate. So this is actually not bad. Okay, I think I need a fresh pair of eyes on this. It's quite late at night and I have been at this for a while now, and it doesn't always work out if you do it that way. Sometimes you need to take a break and have a think about what you're doing. What am I missing? Am I going to end up taking all of the RAM out of this? I'll be back. Right, I've had a good night's sleep and I've come back to this with fresh face and a bushy tail. What I've done is I've got out another ZX Spectrum. This one is my working issue 2. I've put a good ULA into it and that works fine. I can show you that. Can I show you that? No, I can't show you that. I haven't got that plugged in. It's a slightly different, I mean, they're very, very similar. There's not very many differences on here. There's this spider mod here on the CPU is actually this this transistor here is exactly the same thing. So they're very, very similar in many, many ways. Slightly different layout. The ULA has been moved around a little bit. I hadn't actually noticed that before. And the heatsink was in the way over here on the issue 3. It's not in the way here, so this one can just merrily just be switched on and left on, and I can probe around. But this one I had to move the heatsink up off of the board a little bit just to get it out of the way. So the first thing I did was I got the oscilloscope out and I connected it up and I started comparing the signals on some of the lower RAM chips here, these 4116s, and everything looked pretty much normal. There were differences there, but they're the kind of differences I would expect for a machine that's not working and a machine that is working. What I'm looking for is a signal being dragged to ground or being held high for whatever reason. And I found it, but it's not on the RAM. I've ruled out the ROM and the CPU and the ULA. There could be a mechanical problem. There could be a problem with maybe a solder splash somewhere or a broken trace, but I don't think so. The fault that it's showing now is very, very similar to the fault that was showing before I started any work. It hasn't really changed. If anything, it's improved slightly because I've installed a working CPU. The CPU that was in this was not working. Now, because it hasn't changed, I don't think that it's anything that I've done. I haven't introduced a problem by recapping it and maybe breaking something along the way. So where that leaves us now is looking for a problem with the ICs, the silicon that's left on here. I mean, it could be a passive. It's not going to be, well, it's unlikely to be one of the new capacitors. That isn't beyond the realms of possibility that one of them was faulty going in. It could be a broken passive somewhere, but again, that's lower down on the list of likelihood. The more likely things to go wrong here are, well, in order of preference here for me would be the lower RAM, then the upper RAM for what's left, and then the logic chips. So I scoped around on the lower RAM and I couldn't find any problems there. I switched to the logic chips next. I ignored this because I thought if there was a problem here, we're more likely to get a working machine to a certain... It can completely trash the data bus, but it would have been obvious. If it had been a lower RAM or an upper RAM chip, when I scoped these signals here on the Steam Card Pro, I would have seen a data line bad or an address line bad, you would hope. Now, I probably did see something that was bad on here. Let me just make sure that it is here, and then I can actually come back to that in a second. I'm looking for address line 11. It is down here. It's the last one on this point here. I want to check that in a second because I might have seen it. And the benefit of having a working machine to compare something to is when you're scoping something, you might not necessarily see a signal that you can say definitively is bad. The one I'm looking at here, actually, let's get both of these connected up and switched on. Pin 5 of IC3. And look, if I'd have seen that, I might not. I mean, I've seen that kind of signal. It does look a bit funky. And if I show you what it should look like, that's what it should look like. Now it's not actually doing anything at all. So right, I'm actually still on pin 5 of IC3 here, and it is still down at ground, but there isn't that slightly funky look to it. It just looks like a ground signal. So it's not doing anything at all. Just make sure I'm not shorting anything out here. Yeah, that's a possibility. Power cycle it. Okay, so now we've got that funkiness going on again, a slightly different picture on the screen. So address line 11 is part of the multiplexing on IC3. It's part of the multiplexing for the computer, which decides where things get written to in memory. And if this is trying to write code into certain parts of memory, it can't tell which parts of memory it's supposed to be in. It will be writing code into the wrong side of memory if this is held low. So this pin, actually, I can show you on the schematic up here. Yeah, pin 5 is here on IC3, and it comes out and it heads over to the CPU. Oh, actually, first of all, where it goes, first of all, it goes up here to one of the keyboard connectors. That's fine. We don't need to really worry about that right now. But it also goes to pin 1 of the CPU. We know the CPU is good, and I'm pretty sure that the address is being generated by the CPU, so pulling that out is not going to help me. It also goes down here to the ROM. Address line 11 is there, pin 23, and I can see a very similar thing if I connect the scope up and 76543. Yeah, that same funky signal is there on there. And a good experiment, if this was, if I hadn't already verified that this was a working ROM, which I have, I could take this out, turn it back on again, 76543, and we can still see that rotten signal. Slightly different, in fact, very different because I haven't got the ground connected. There we go. Didn't really seem to make much difference. Okay, so the ROM is definitely ruled out. Does it go anywhere else? Address 11 is there on the edge connector, and there on IC25 pin 5. So IC25 is this one here. Let's quickly scope that one as well. That's pin 5, and we've got the same thing going on there. The question is, what's causing the problem? It's not the ULA. Address line 11 doesn't go through the ULA. So it's not the ULA, it can't be the ULA. Right, anyway, back on track. So we've got IC25 and IC3. Both of them, pin 5 is a problem here. Which one of those is causing the issue? Now, I could just pull the chips out and test them, but there's another way. And I've spoken about this before on the channel. I've spoken about the happy little diodes method. Now, some technicians, I'm not going to name any names, would just chop that leg off halfway up, and if it wasn't that pin, they would just solder it back on. I really don't like doing that. I quite like making my life a bit more difficult. So I've bought these. These are, I don't know what they're called. There's some Chinese writing on there, but I don't know what that says, and I'm not going to translate it. But they are basically pins, hollow pins, and these are a desoldering tool. And what I'm going to do is I'm actually going to heat up the desoldering gun. I'm going to get as much solder as I can out of pin 5 on both of these chips here, and separate them from the hole around it, so that they're not electrically connected, by using one of these just to ease the pin away from the outside of it. This is something that is used on these boards, not these boards specifically but on. This is a way of actually desoldering a pin on a leg. I'm not sure I've got the right size here. It might be the blue one. This is going to be a little bit... I've never done this before, so a little bit of trial and error. It might be the green one. I reckon it's one of those two. But we'll find out. Once the desoldering station is warmed up, I'll try it. Workbench is getting crazy. I'm probably going to have to change this 7805 because putting in this... bending up the regulator like this with the heatsink hanging up in the air puts a lot of strain on these legs. You have to actually bend them, and when you bend them back, it's a good chance that they'll just break, but it's not a big problem. I can just pop another 7805 in there. I'm not worried about that. I've got plenty of spares, but I'm going to leave it there for now. Right, so we're looking at pin 5 on these two ICs here. And I'm going to flow some solder in there first. A good amount of it. Just so that I can get good thermal conductivity with my desolder station. So much stuff in the way. I really need to have a clear up, but I'm just too excited about trying to fix this. Give this a good melt. And this one. Okay. Let's try the green one first. It's got to fit into the via. And that one doesn't. I think it might be the blue one. It's also got to fit over the pin. Ah. Yeah, that is the kiddie. This will have a couple of effects. One will be to separate it from any remaining solder, but also to straighten the leg. I'm hoping that's going to be it. Much more difficult to do from this side. Don't think we've got it yet. No. These might be just jammed down into the vias too much to actually be separated, but I will try. I'll come back to you in a sec. Try a little bit of desoldering braid along the edge, along this top side, just in case there's some more solder hanging around there. Oh, that looks clearer. I don't think it's going to work though. I think there's just too much leg in the hole. Yeah, even moving it around doesn't make any difference. So what I'm going to do is actually just remove... Actually, do you know what I'm going to do first? I'm going to solder them back on, and I'm going to measure the resistance and see which one is the lower resistance and take that one out. Does that sound like a good idea? It sounds like a good idea to me. Let's put this into resistance and connect it to that pin there. 11.6 on 11.4 on IC25 and pin 5 on this one. 11.2. Yeah, there's not much in it, but I'm guessing IC3 is the one from that. Let's try that. Let's pop that out and see what happens. I've really rarely had... These are a point of failure, the logic chips. It's something that can go wrong. But they're usually pretty reliable, and I can't remember having a logic chip fail on a Spectrum before. that I've repaired. So this is quite an interesting one for me. Oh, and I've measured the resistance on that line on the other spectrum, and there's no resistance there at all that my multimeter can find. So one of these chips is shorted internally. Not quite. I'm going to try what I did before with the other chip and just moving these legs with the soldering iron just to free them up that last little bit. Oh, that works really well. Okay, so with that actually being a short, if it is a short, let's test that, because I can test that now between pin 8 and pin 5 here. If I've got 10 ohms short, or around about 10 ohms short here, 1, 2, 3, 4, 5, then this is the chip. Yeah, 20 ohms short. 20 ohm short is not right, so that should actually show up in a chip tester. And I have a chip tester here. This should show up as a faulty chip. Not found. Let's get a new one. Oh, I've got some more Z80s on here. I didn't realise. Excellent. I thought I was going to run out. Right, a 157. Anybody seen a 157? Please raise your hands. 157, 74 LS 157. LS 157. One more go. Okay, I'm not ruling out the other chip being faulty. So we need to bear that in mind. It could still be that one, but we'll work on the premise that it's that this is the fault. We've already found a couple of faults. There might be more. I reckon with 2 chips gone bad in a board, it's likely that there has been something that's caused that, probably over voltage or incorrect polarity. More than likely over voltage. No, it can't be over voltage. The 7805 would have gone. And usually the 7805 with incorrect polarity will just pop. But you would have expected that the 7805 to have been popped as well. I'm not sure. It could have been something going into the edge connector and shorting out some, maybe the 12 volt got shorted to something. I wonder where the 12 volt lives, what lines it lives next to on the edge connector. No, it's miles away. Miles away from A11. Right, so where we've got 2 chips gone, we could have 3. This could be just part of the problem. I'd like it to be the end of the problem, because I just want to get this one edited and finished. Okay, there's no heatsink on the 7805. I'll only be able to turn it on for a second. There's still a problem. There is still a problem. Okay, I'm going to put the heatsink back on and we shall continue. This one's not done with us. So I'm Lee from the future. This is Editing Lee, who's got up from the desk to walk over to the bench in front of the camera to tell you that's as much as you're going to see for this episode. There is a lot more to come, and I have to admit that at the time of recording this, the computer is still not repaired. So I can't promise that there's going to be a satisfying conclusion to this, but I will do my best. There's still more to come. There's more to see. So I hope you enjoyed my struggle so far. It really has been a bit of a struggle, but I'm confident that we're going to get somewhere. Okay, thanks for watching this one, and I'll see you in the next one. Bye.